Hi guys, in this video we're going to talk about Coulomb's law. That's pronounced Coulomb, like coo, like you're a pigeon, loam, like it doesn't even have a B in it. Coulomb, Coulomb's law. And I'm going to use my trusty Cornell paper because I have good luck with trusty Cornell paper. And the topic that we're going to be talking about, like I said, is Coulomb's law. And you put your name, class period, and date over there. Our essential question is, how is Coulomb's law used to calculate electric force? Or another variable. Sometimes we want to find some other piece of information. So let's review what Coulomb's law says. We talked a little bit about electric force and things that it depends on, Coulomb's law. And then this is the equation that sums it all up. So this is going to be a little bit mathy. So it says that Coulomb's law says that the electric force increases with each charge. That means if you increase one charge, it goes up, and if you increase the other charge, it goes up, and if you increase both charges, it goes up even more. And it decreases with the square of distance. That means that if you change the distance a little, the force changes a bit more, and it goes down. So what this looks like in an equation is that the electric force, Fe, is going to have K, which is just a constant, Q1, Q2, that's each charge, and then the distance is squared, R squared. So when it's on the bottom, that makes it get smaller, and when it's on the top, that makes it get bigger, so that's why the Q's are on top and those are on bottom. So let's talk about what all those things are. First, K. K is called Coulomb's constant, and it's a constant. So that means it has a value that you need to know, and it is 9 times 10 to the 9th Newton meters squared per Coulomb squared. That's just a unit. The Coulomb is the unit of charge, and so the Coulomb squared gets canceled out here. And the meters is a unit of distance, so the meter squared gets canceled out here, so that the force is measured in newtons. That's the whole purpose there. Q1 and Q2, those are the charges that are involved, and those will always be measured in coulombs. That's the unit of charge, which is a capital C. Coulomb is the unit of charge. It's a capital C. You can jot that down too if you'd like. R represents the distance between the charges in meters, and a note here, don't forget to square it. When students have issues using this equation, it's because they forgot to square R. Okay, so you got to square it. So on the back side of this Cornell paper, we're going to talk about how to use this to solve some problems. Whoops, problem solving. And so we're going to write down some, this is my basic method here. I call it the guess method, guess. So in physics 2, you're going to be guessing some equations here, but guessing is what you're going to do. G stands for givens. That's where you write down what you know. U stands for unknowns. That's where you write down what you don't know. E stands for equation. That's where you write down the formula, that thing that we just wrote up here, formula, the equation that you need to use. S is where you stick in the numbers or substitute. And then the second S is for solve. That's where you find your answer. Okay? So that's what we're going to be using. Now, one other thing that is useful to write down that I just remembered is that when we're talking about an electron has a very particular charge, and it is 1.602 times 10 to the minus 19 coulombs. And a proton, by the way, that's negative. A proton has the same charge, it's just positive, 1.602 times 10 to the minus 19 coulombs. Okay, so should you be doing a problem and it says you have an electron or a proton, but it doesn't tell you the charge, that's because it's known. It's right there, electron, proton. Okay, so let's look at some practice problems. Now the practice problems I'm going to look at are in your packet. This is the first question right here. Oops, there we go. This is the first question here. It says example 1. These are your notes in your in your notebook if you wanted to take a look at those and do some highlighting, but this is example one that we're going to be looking at on my Cornell paper. Get that situated here. Excuse me. Whoa, bumping into stuff. Okay, so we've got these charges here. Are you kidding me? Okay, it is still recording. Okay, sorry, my computer's being crazy. Okay, so we have these charges here. It says, and it even tells us how much, so we're going to start with our givens. It says we have a charge of plus 0.03, so I'm going to call that Q1, plus 0.03 coulombs, and another one that's plus 0.07 coulombs, so that's Q2, plus 0.07 coulombs, and they're placed a distance, that's R, of 4 meters apart. First we have to draw a picture, it says, that shows the direction of each force, and then we have to calculate the force felt by each of the charges. Now, so my unknown is the force. I need to find the force. My equation is that equation that we just wrote down, Fe equals K Q1 Q2 over R squared. So now I'm going to go ahead and put my numbers in. My numbers are going to be, let's see, start with my Fe. K is that 9 times 10 to the 9th meters squared per coulomb squared. Q1 is 0.03 coulombs. Q2 is 0.07 coulombs. And then my distance is 4 meters, and I have to remember to square that. Now this is going to be kind of tricky to do on one of these calculators. So I would suggest using one of these calculators or a scientific calculator. Hopefully you can see this one at least reasonably well. Oh, you can see a reflection of my head there. Okay, so this is an old calculator. It's missing a few lines every now and then. So I'm going to go ahead and plug this in. So I'm going to do the stuff on the top first. Now to get this scientific notation number, I use this button right here that says EE on it. On the 83s and 84s, you have to hit second and it's above the comma. I think it's a comma. So I'm going to use that button. Let's see if I can get this where you can see it. I don't know. Okay, so 9 times 10 to the 9th. And then all I'm entering here, there we go, is the number in front of the times 10 and the exponent. So that's 9 times 10 to the 9th. 9 is the exponent, so it's 9E9 is what it looks like in my calculator when I use that button there. If you have a scientific calculator, please ask me if you have any questions on how to do this on the calculator that you're using. I'll be happy to help you. So I'm going to take that number and multiply it by 0.03 and then multiply that by 0.07. So on the top I have a big ugly number. My calculator has written out those numbers, so it's 189000000. Is that right? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Okay. So that's my number on top. Now I have to divide that by the number on bottom, which is going to be 4 squared, which is 16. So that's what I got to plug into my calculator. That number divided by 16. And I get 1181250 newtons. Okay. Yeah, that's a pretty big number. That's a lot of force. I mean, I only weigh 660 some odd newtons, so that's a pretty big value right there. Okay, so that is an example right there. Oh, we got to draw the picture. We got to draw the forces. Okay, so here is my charge, and here is my other charge. This is the plus 03, and this is the plus 07 point. There's a point there. Okay. Now, since they're both positive, are they pulling or pushing? Both positive is pushing, so I'm going to draw my arrows pointing away from each other. Okay. Now, Newton's third law says that those have to be the same. Newton's third law says that those are equal forces because if this one pushes on this one pushes on this with the same amount of force. So equal forces, opposite direction. So that's how I know my arrows should be drawn the same. Now, if that's enough of an example for you and you're ready to go get started, by all means go right ahead. If you need further examples, watch an additional video. Thanks for watching.